Okay, so welcome to episode 3 of our physics playlist, and in this episode, we'll be doing vector addition in 2 dimensions. So in the last episode, we did vector addition in one dimension as seen through here. We just did it all in one direction, and it was pretty simple because it followed our normal mathematical rules of addition. However, what if vectors were not in all in one direction? What if we had vectors like these plus this? What happens? So we're going to talk about that later on. So let's create a new space. Okay, so let's delete that, and we're going to keep all of this so that we can reference it. Okay, so how do we add a vector of like something like that to a vector that is pointing this way? So I'm just going to put these vectors here. So how do we add these vectors together? So first of all, let's give them names. I'm going to give this vector A again. Vector A. Oh, why is it red? Vector A equals, that looks about like 5 kilometers. And is it north? We haven't given any reference point yet, so we're just going to call it up. If we actually had a reference point like last time where we had the north, south, east, west thing, then we call this north. But since we don't have one, we're just going to call it up. Now, I almost forgot the arrowhead. So vector A equals 5 kilometers up. And how about this vector? We're going to call this vector B, and this one looks about 2 kilometers. 2 kilometers where? Right. So there we go. Just expand that. Okay. So there we have it. So we have vector A, which is 5 kilometers up, and vector B, which is 2 kilometers up. Now, how do we add these two together? Same rule as before. Rule for addition. Let's refer to it again. We place a tail of one vector, doesn't matter which one, on top of the head of the other vector, and then the sum would be just drawing another vector from the start to the end. So if we chose A as our base vector that we're going to add B onto, so I'm just going to put these all to the side. We all know that A is up and B is right, so I just don't want to get these in the way of my diagram. So okay, so this is B and this is A. So we have A. Now we need to place the tail of B, and we know that the tail is the one that's not the head. So place the tail. Oh, I cut off a bit there. So it's not okay. It's gonna cut off a bit because pane doesn't really let you overlap. So I guess that works. Okay, so we place the tail of vector B, which is 2 kilometers right, onto the head of A, which is 5 kilometers up. Now, how do we add the vectors together? What does our rule say? It says that the sum of the vectors of A and B would be the arrow that is drawn from the start, which is over here, which is where we started. We started and we ended here because we traveled along this line. So we went 5 kilometers up and we went 2 kilometers right. So imagine that like a person walking along this line, following the arrow, 5 kilometers up, 2 kilometers right. So he started here, he ended here. So we draw a line there. So I'm going to use the red line to draw it. So he started from here, and he ended here. Okay, so that is the sum of the vectors. And as last time, I showed you that to signify that, to tell the reader that this is a resultant, not one of the vectors that was used in the problem that are being added together, we use the 2 arrowheads in the body. So let's give it a name, and we know what the name is. It's A plus B, and it's red again. Gotta change it back to black. A plus B equals, we do not know this yet. So this lesson will be me trying to teach you how to find this value. So we know that, wrong one. We know that A is 5 kilometers up, and that B is 2 kilometers right. Now, and we also know that this is a right angle triangle because up and right are at right angles to each other. So I'm just going to draw, oh, that sucks, draw a right angle thing here. You know, that little box thing. So this is a right triangle. So with right triangles, what can you use to find this side? Knowing this side, the length of this side, and the length of this side. The length of this side. Well, we can use something called Pythagoras. And what is the formula for Pythagoras? The Pythagorean theorem, which is a squared, and I can write a squared, the little superscript too, because I can do that in Paint. And so I'll use the caret for now. A caret 2 means a squared plus b squared equals c squared. And c squared is the hypotenuse, and a squared and b squared are the other two sides. So since we know, well, it coincidentally coincides with our a and b. So a squared would be 5 squared plus whatever b is, which is 2 squared, equals c squared. Now 5 squared is 25 plus 2 squared is 4. Oh, this isn't a pretty number. And just c squared. So 29 equals c squared. And c equals, now I need a calculator for this because this isn't a pretty number. I should have chosen one which was prettier. So it's about 5.4 rounded. 5.38, but 5.4. I'm just going to call it 5.4. So we know that a plus, well, c is the hypotenuse, which is also a plus b. So we know that a plus b equals to 5.4 what? Kilometers, because we are dealing with kilometers here. And what's the direction? Because it's a vector, which I forgot to tell you guys because I didn't put the vector hats. Oops. Vector a plus vector b. There we go. So vector a plus vector b equals 5.4 kilometers in what direction? Now it's not exactly north, it's not, I mean up, it's not exactly right. So what is it? And I already told you guys this in the very first lesson if you guys remember, but in case you don't, that's completely alright. So let me just tell you guys again, for those of you who didn't watch the first lesson. What you would do is you would use, hold on, I'm going to shift this over. How would you solve this? Let's try to make it give me as much room as possible. There we go. Okay, so how would you find the angle? How do you find direction? Now, to express the direction of this resultant, you need to find the angle between vector A and vector B. So, how do you find this angle knowing all three sides? We use not Pythagoras, trigonometry. And so we have 3 different ways we can do this: sine, cos, and tan. But the way that I recommend you to use is always use the one that requires the 2 variables that were given to you in the question. Do not, and I repeat, do not use the number that you yourself calculated, because if you calculated this number wrong and use it in finding your angle, then your angle would also be wrong. So I highly recommend you use the numbers that were given to you in a question, which is in this case is a and b, which is opposite and adjacent. So which trigonometric function uses that? Opposite over adjacent? Tangent. So tan theta, and I can write theta on Paint, so I'm just going to write t. Tan theta equals opposite over adjacent, because tan equals opposite over adjacent, which is 2. The opposite side is 2, and the adjacent side is 5. And I need to use my calculator for this, and you'll get theta equals, hold on, just give me a second here, 2 over 5, and inverse tan, and you get an angle of about 21.8 degrees. And I can't write degrees here, obviously, because, you know, I don't have anything drawn. I guess I could just use this and draw a little degree thing here. And I can draw like theta. Oops, that's a bad theta. There we go. And then theta here too, whatever. I'm going to draw that. So, so we know that this angle right here is 21.8 degrees. And we can finally fill out the direction, which is, what is direction? Well, what is this angle actually? What does this angle represent? What does the 21.8 degrees represent actually? It is the angle between the up direction and your resultant. And since you want to find the direction for resultant, and the way to express that would be from the up going 21.8 degrees, which is this angle, from the up going, let me see if I can do it here. I'm going to use a green arrow to see if I can show you better. From the up direction, traveling 21.8 degrees to the right. So let me repeat that. From the up, 21.8 degrees to the right. And we land on the vector. So let's put it down. How do you write? How do we write that? Well, using the square brackets as usual. Oh, wrong color as usual. Square brackets, up, since we have up, 21, actually I'm just copy it later on, 21.8 degrees right. Oops. And I'm going to draw, the reason why I had a little space for me, I put a little space there for me to draw a little degree sign. There we go. So this is our answer. So what is the sum of two vectors of vector A? Where did my vectors go? Oh, I deleted them. Oh, it's right here. Wow, I thought I deleted them. So what is the sum of A plus B? So what is A plus B? What is vector A, which is 5 kilometers up, plus vector B, which is 2 kilometers right? The answer equals, now I'm going to draw a little equal sign, equals, and equals what? Equals, oh, I can't, screw it. Okay, well, it's right here. Equals this. So, and a vector that goes 5 kilometers up, and then plus added to a vector of 2 kilometers going right, we get the total vector, the resultant vector, or net vector, whatever you want to call it, of 5.4 kilometers up 21.8 degrees right. And that is how you add vectors in 2 dimensions. And also, remember, once again, I'm going to repeat this once again because some people might get confused. It does not matter which vector you add to which. For example, let me show you that right now. So I'm just going to keep this answer right here because I'm going to show you that it's exactly the same. You get exactly the same answer. So, using this line, let's say this is the vector that you're adding to, and this is the vector that you're adding to vector. So you're adding vector A to vector B now. So what does our rule say? Place the tail of one vector on top of the head of the other vector. Okay, something like that. It's a bit off. Let me try it again. And I know it looks kind of bad because I just cut out and pasted, but so it looks kind of bad, but you know what I mean. So let me just draw it because it's the arrow is kind of demented now. So there you go. So we know this is A, and then this is B. So B is this one. Oh, oops. So B is this one, and A is this one. Okay. So instead of placing B on A, we're placing A on B now. So the tail of A placing on the head of B. And what is our vector? Well, let's see here. Using red again. From the start, remember, the sum of the vectors is the arrow drawn from the start, which is this, to the end. Where is the end? And the end is here. And then we draw 2 vector heads in the body. Now, what do you see? Ta-da! These 2 vectors are exactly the same. Well, as the same as you can get with my bad drawing. But you know, theoretically it should be the exact same length, exact same angle. Both should be exactly parallel. And what is the length of this, you might ask? Well, using Pythagoras, a squared plus b squared equals c squared. and A is still 5, B is still 2, and you get the same answer. So it's still 5.4. And what is the angle? Well, what is the angle? We want to find the angle here. So what's the angle? Let me write it down here. So what are we using now this time? We want to find the angle, and remember, we want to use the angle that were given, the lengths that were given to us in the question. So 5 and 2. So we can use tan again. So tan t, or theta, equals O. Now O in this case is not 2, it's 5, because 5 is the opposite side to the angle. 5 over 2, which equals 2. T equals, hold on, I'm going to bring out my calculator. 5 over 2 equals inverse tan, 68.2 degrees. And what do you notice here? 68.2 plus 21.8 equals 90 degrees. And I'll show you why. Remember when I was talking about in the first episode, there are two different ways you can express the direction. Here, let me draw that out right now. If you have, this is pointing up to, so this is parallel to this. Now, we know that this angle right here is 68.2 degrees. What is this? If this is right and this is up, and so then this must be a right angle, right? What is this angle? Well, the angle is basically 90 minus 68.2, which equals 21.8, as figured out just now. So both, it doesn't matter which arrow you add to which, you still get the right answer. And in this case, we got 68.2, and if we wanted to leave it in 68.2, our answer would be 5.4 kilometers. Direction of where? This angle is between the vector and the right direction this time instead of up. So we have right, and then going 68.2 degrees up. Now both are exactly the same as you saw just now. Right 68.2 degrees up is the exact same as up 21.8 degrees right. Here, let me show you. So in this one it was up. Oops. In this one it was up, and then you move 21.8 degrees to the right. However, now we're starting from the right, and we're traveling 68.2 degrees up, landing on the same spot as if you went the other way. So both ways are acceptable, but as once again, your teachers will prefer if you use the angle that is less than 45 degrees. So in this case, the preferred answer would be this one, the first one. So let me reinforce this idea one more time. It does not matter which factor you add on to which. Both should result in the exact same answer. So yep, that's about it for vector addition in 2 dimensions. And next episode, we will be talking about vector subtraction, which is really simple actually. But until then, I'll see you guys. Peace out. Okay, just before I go, I just want to add that when I'm talking about the angle between the direction of the resultant, the angle, I am talking about the angle is the angle between where the tails of the resultant and one of the vectors are touching. So in this case, the tail of the resultant is touching the tail of this vector that's pointing up. So over here. So basically, the angle is the angle where it starts, where the diagram starts. So the start is here. So the angle should be here. The angle should be in the little angle spot. And the angle should be the angle that contains the start position. So it cannot be this one, and it obviously cannot be this one because it's just right angle. So it has to be the angle that is at the start or the tail of the resultant. So just want to make that clear. So yeah, thank you guys for watching once again. Bye.